Hello student, this is the continuation of the earlier video where we have differentiated an aldehyde and a ketone by oxidation method. In this video, we will be learning how to distinguish between an aldehyde and a ketone using the reduction method. So when I take the carbonite, this is the functional group that is present in the carbonate compound where a carbon is the double bonded with an oxygen. The oxygen being more electronegative in nature gets a partial negative charge and carbon gets a partial positive charge. Generally, because of the presence of the double bond, an addition reaction occurs, and here it is a nucleophilic addition reaction. So, coming back to the reduction, the reduction process is a addition of an hydrogen or it is a loss of oxygen, which is exactly the vice versa. So a gain of hydrogen or a loss of oxygen is a characteristic feature of any reduction reaction and any reducing agent can be used for this process. So whenever we do a reduction of a carbonyl compound, generally we get an alcohol. So as I said, a reduction involves the addition of hydrogen across the molecule. So a carbonyl compound will, upon reduction with any of the reducing agent, here we get an alcohol. So here there is an addition of hydrogen across the double bond to give the corresponding product, the alcohol. When I take the aldehydes generally give the primary alcohol. Ketones gives the secondary alcohol. So when I do a reduction of an aldehyde gives a primary alcohol and a ketone upon reduction gives us a secondary alcohol. There are various reduction methods. In this video, we'll be learning with the hydrogenation and reduction with sodium boron hydride. Coming to the catalytic hydrogenation, so aldehydes and ketone on hydrogenation with the molecular hydrogen in the presence of nickel or platinum produces the primary and secondary alcohol respectively. So let us look at the reduction of a carbonyl compound. We get an alcohol. Here H is the reducing molecular hydrogen is the reducing agent. So when I take an aldehyde, we get a primary alcohol. So a primary alcohol is the one which has only one alkyl group or it has two hydrogen atoms. So a primary alcohol is obtained on reduction of an aldehyde. Whereas a ketone undergo the reduction, we get a secondary alcohol where we have two alkyl or aride and only one hydrogen and hence it is a secondary alcohol. So the general representation of a reduction reaction is as follows. So I take an aldehyde or a ketone. So in a aldehyde I have a hydrogen. In a ketone I have an alkyl or a aryl group. So the carbon has been double bonded with an oxygen where we have one sigma and one pi bond. Upon the reduction in either of the reducing agent, there will be addition of hydrogen across the double bond. One of the hydrogen is added to the oxygen and other to the carbon carrying the functional group and a new sigma bond is formed across this. So the product can be a primary or a secondary alcohol. So let us take an example of an aldehyde propanol. So as I said, there is a addition of hydrogen in the reduction process and one of the hydrogen is added to the oxygen and other to the carbon which is carrying the functional group and I get the primary alcohol in the case of an aldehyde. So propanol upon reduction gives the propyl alcohol or 1 propanol which is a primary alcohol. So like this, let me take a ketone. It is dimethyl ketone or propanol. Upon hydrogenation in the presence of nickel or platinum, we get the addition of hydrogen across the same scenario, the oxygen and the carbon with the functional group, and I get the corresponding secondary alcohol, and here it is 2-propanol, which is a secondary alcohol, and here we have two alkyl groups and only one hydrogen, and hence it is a secondary alcohol. And coming, let us look the reduction of aldehydes and ketone using sodium boron hydride as a reducing agent. So sodium boron hydride is obtained when the boron is treated with sodium hydride. We get the corresponding sodium boron hydride, and here the solvent can be a water or alcohol, and it is an excellent reducing agent for the aldehydes and ketone. So here there is a nucleophilic addition across the C double bond oxygen, and it get converted into CHOH. So here the sodium boron hydrate is a donor of hydrate ion. So the hydrate ion, which is the produced from sodium boron hydrate, attacks the sp2 carbonyl carbon, leading to sp3 tetrahedral intermediate. This is followed by the addition of a proton or a protonation of this aloxide ion results in the formation of the alcohol. This is the mechanism of reduction by using sodium boron hydrate as a reducing agent in the carbonyl compounds, that is the aldehydes and ketones. And let us look in detail the reduction of aldehydes to primary alcohol. So these are the key bond that has been formed, that is bond between hydrogen and a carbon and a bond between oxygen and the hydrogen. The bonds that have been broken are between the carbon and the oxygen, that is the pi bond is been broken. For example, when I take the acetaldehyde upon reduction, I get the primary alcohol, that is the ethyl alcohol. So the next thing is the reduction of a ketone. So I results in a secondary alcohol. So here the reducing agent is sodium boron hydride. For example, when we take the acetone sodium boron hydride as a reducing agent, a corresponding alcohol, that is a secondary alcohol, that is the isopropyl alcohol is being formed, and the mechanism remains the same. And the important thing is the ketones can be reduced to give the pinacol. So ketones, when we take two molecules of acetone in presence of magnesium and mercury, it results in the formation of a completely substituted diol, that is the pinacol, which is 2,3-dimethyl 2,3-butane diol. So ketones can be reduced to pinacol, but aldehydes do not form the pinacol. Thus, the aldehydes and ketone can be differentiated with the reduction. So we know the aldehydes upon reduction gives a primary alcohol, ketone upon reduction gives the secondary alcohol, and ketones can be converted into pinacol, but aldehydes cannot be converted into pinacol. Thank you.